A rocket has a positive velocity after being launched upward from an initial height of 0 feet at time t equals 0 seconds. The velocity of the rocket is recorded for selected values of t over the interval from 0 to 80, as indicated in the table below. Using correct units, explain the meaning of this definite interval in terms of the rocket's flight. Use a trapezoidal sum with 4 subintervals of equal length to approximate this. So we're going to come back to the correct units and explaining the meaning. Let's first start off with finding out what it's equal to. So we're trying to find an approximate value of the definite interval from 10 to 50 of the velocity, and we have this table. So we're not using the whole table, we're just using this portion of the table. And luckily for us, it's going up by 10 each time. So our delta t is 10. We have the same change in t the whole time. So we can use our formula. We have 1/2 times delta t, which is 10, times f of 10, which would be 14, plus 2 times f of 20, which would be 20, plus 2 times 29, plus 2 times 35, plus 40. Remember, first and last ones are only used once, and everything in between is used twice, because it's part of 2 different trapezoids. If we were to go ahead and add all that up, we should have approximately equal to here, since we're doing approximation. This is approximately equal to 1,130. But we're asked to figure out what units this is. And on an AP question, if it asks for units, it's giving points for that. So we want to make sure that we provide the units. Remember, we're representing the area under the curve. So we're going to look at kind of a crude graph here for just a second. We know that the x value is represented by t in seconds, and our y value is the velocity, which is represented in feet per second. So if we're looking at a curve on here and finding the area, we're taking these 2 dimensions to find the area, right? Seconds times feet per second. So feet per second times seconds. If we multiply those, the seconds cancel out, and we're left with feet. So the units that we're using for this are feet. We can find the area under the curve, and when we're talking about units, we're just taking these units times these units. We're multiplying those, so whatever we had left, in this case, seconds cancel out, and we're left with feet. Now, the question also asks us to explain the meaning of this definite interval. All right, so we've got 1,130 feet. But what is that telling us? Well, this definite integral is telling us the distance that the rocket has traveled in this time period, from 10 to 50. So 1,130 feet is the distance the rocket travels from t equals 10 seconds to t equals 50 seconds. So in that 40-second time span, the rocket travels 1,130 feet.